Hi everyone. So for this section, I'm going to discuss the experiment 3, which is to compare the performance of the Ensemble models. So before we comparing the performance, let us see what we are actually predicting. In this project, we are doing classification on mobile price range. So that we have 3 classes to be predicted, which are low range, medium range, and high range. So for low range, which means that the phone price is below 500 ringgit, and medium range is between 500 and 1 ringgit to 1,500 ringgit. And then for the high range, which means that the price is above 100 1,500 ringgit. So in this experiment, we are using F1 vectors for scoring purpose. As here we can see that our training data target distribution, which are highly imbalanced, so we decided to use F1 vector metrics rather than using accuracy metrics. So also have to mention that for our data, we are splitting it into 80% for training and then 20% for the testing part. So the cross-validation and hyperparameter tuning will only perform on the training data, and the testing data will only use for evaluation purpose only. So now comes to the main parts for this section. In Ensemble learning, we have constructed 3 models which are random forest, gradient boosting, and also stacking models. So in this slide, we are showing the models with default parameters tuning, which means the score before we doing the hyperparameter tuning. So in this part, our stacking model will not be compared as we do not do any hyperparameter tuning. We will do that. We'll discuss that on next slide. So let us see the 2 model first, which is the random forest and gradient boosting. So by comparing these 2 performance, random forest actually score better than gradient boosting in the testing data, but gradient boosting score better in the cross validation. So let us see the next slide. So to further improve our scoring on the F1 matrix, so the grid search and the grid for the hyperparameter tuning and also the best performing parameters are showing on this table. So by observing at the test result, the gradient boosting algorithm actually is the best model as it scored around 68% on the testing data, with its best parameter learning rate is 0.1, max step is 5, and n estimator is 100. So the second best model is our stacking models. So our stacking model actually we did not do any parameters tuning. We are using the parameters that we got from previous model in order to feed in our level 1 estimators, which contain random forest, gradient boosting, KNN, and also decision tree. And then for the final estimator in our stacking models, actually we are using logistic regression. So as you see on the table, the cost validation score in stacking model is around 70%, but unfortunately in the testing data, it does not perform as well as cross validation. It only contains 67%. So we can say that the best model is still our gradient boosting method, gradient boosting models, because it achieves highest score in the testing data. In this slide, we are comparing the models between default and after we find the best parameter. So we can see the gradient boosting actually improved after we perform hyperparameter tuning. It improved around around few percent, and random forest actually did not improve the performance. It dropped around 5% when performing in the testing data. And then for stacking model, you can see that just one bar showing at there because we do not compare the default and after the parameter because we did not do hyperparameter tuning for our stacking model. So from the result, we can see that gradient boosting model is the best performing model among the others. So in conclusion, the best ensemble model in this experiment that we can get is gradient boosting method. As I mentioned just now, it scored around 68% in testing data. And then the second highest model is stacking model. It scored around 67% in testing data. And lastly, for the random forest model, it got the lowest score, which is 62%. And we suspected that this model is actually overfitted on the training data because the validation score is 68%, but during the testing data, when we perform it on the testing data, it score only around 62%. So we suspected that this model is overfitted on the training data. Yeah, so I think that's all from my part. Thank you.